Innovative system diagnostics can help startup commission be fast and efficient, as well as mitigate downtime dramatically. Let me show you how innovative they can be. So as you can see, here's our current control system. We have an S7-1500 with some local I/O. We have the E200SP distributed I/O, as well as a comfort panel, and all of which is on Profinet. Well, in our project, if we come over here to the main blocks, here you can see I do have my main program. However, there are no diagnostic blocks with him. Also too, if I give focus to my CPU, go down to System Diagnostics, the box is checked for Activate System Diagnostics all the time. So the S7-1500 in V12 software, it's at the firmware level, not in the actual program. Well, all we have to do is activate what we want to see in the actual modules themselves. Well, let's get started with that. Let's go to this DO module right here in the 1500 rack. Go down to no supply voltage. That makes sense. Let me go to the network view, go to the E200SP, give focus to him. Now I've got focus on him. I'm going to go to this AI card right here, give focus to that card, and we got it plus or minus 10 volt. I want to make that plus or minus 5 volt. So let me change that real quick. Go back to the diagnostics for that one and change it to an overflow. Let's give focus to the main CPU, click the download arrow button. Now it's going to compile the fact that I've made these changes from a diagnostic standpoint, as well as this plus or minus 5 volt for that particular card. He's accepted that from compile. Let me click the load button. Now he's going to load that down to the CPU. I can click on finished, and those diagnostics are now complete. How about the HMI? Let's give focus to the diagnostic screen. And let me go over to my controls section here. Go drag this diagnostic viewer window directly onto the diagnostic screen, resize, refit him. Let me go back to the actual control screen, give focus to him. Now let's go over to our libraries. Let me go down to buttons and switches, down to diagnostic indicator, drag and drop that onto the screen. Now let's go back and grab the diagnostic screen and drag it over the top of that button so we can indicate on the control screen. Give focus to the HMI. Click the download arrow button. Now he's going to compile the fact that I've made these changes as well. That was an ActiveX control from our standard libraries that we have. That way we can populate the diagnostic messages into that ActiveX control. Click on overwrite all, click on load. Now he's going to load that configuration down to the actual panel itself. As you can see here in the runtime settings, it is actually loading to the panel at this point. And it's also going to add in this little control icon directly onto the actual control screen, as well as that new diagnostic viewer window onto the diagnostic screen. Now it is finished. He's going to refresh. You can see there's the diagnostic indicator, so now our load is complete. Okay, so how about the diagnostics? First, I like to start with S7-1500's web server. What I need to do is go over to the actual navigator. Let me go find this IP address of 192.168.0.1. There it is. Click on enter, and as you can see here in the actual web server as well as the controller, I have all green LEDs. So let's generate a fault. Let me come over to the E200SPIO. Let me pull out his card. You can see in the actual distributor rack as well as the master, I do have some kind of error fault. The web server is showing me the same thing with the same LEDs in the same location. Let me come over to the diagnostic buffer. The very first message is hardware component removed or missing. That is correct, and in fact it even tells me all the way down to the part number and exactly where this fault is in the automation architecture. And the beautiful thing is I did all this without one single line of code. Let me solve the problem. Put this back into his rack. So the I/O and the master and the web server all agree the fault is cleared. So how about this actual display directly on the 1500 itself? Let me actually put this in the stop mode first, the CPU. You can see it's clear in the stop mode. And if you remember, this analog card, I'd actually turn it to a plus or minus 5 volt instead of plus or minus 10 volt. So I can actually generate a message off of him. If I move this slider above that plus or minus 5 volt, I've got some kind of diagnostic here, so I can actually navigate over to Diagnostics, click OK, Alarms, click OK. He's going to go out and try to find out what this fault really is. High limit exceeded, that is correct, that's exactly what we actually programmed for. And the beautiful thing is this is even in the stop mode. So before you start up your machine, you can actually find your faults, solve them, and start up in a safe state. Let me solve the problem real quick. Our problem solved. I don't see any more red LEDs. I can escape back out of this guy. And last but not least, wouldn't it be great if I could actually generate these messages up to the HMI on the machine, even in the stop mode? Well, we can. If I come over to this card right here, if you remember I did no supply voltage for this guy, if I pull him out, you see the diagnostic indicator on the HMI has turned red and there's a wrench now. If I click on that, I'll see I have some kind of message in this actual local hardware architecture. I can click on this button right here. It's actually going to generate the ring buffer for him and show all the diagnostic messages. No supply voltage, that is correct. Click on the plus sign over here to find physically what it is. It tells us exactly that there is no supply voltage all the way down to the actual card in the rack and potentially how to solve the problem, including the part number, and not one line of code was required to achieve this. Now that is engineering efficiency.